Okay, so one thing I'm realizing is a lot of times people, you guys, a lot of times folks are getting caught up on how do I know to do this? And the idea is either I have at least one sibling or I have no siblings, right? So either have at least one 4 or I have no 4s. Those two groups, the probabilities of those groups have to add up to 1 or 100%, so you have to do one or the other. So that means that whatever you get in the no 4s plus whatever you get of the at least 4s has to add up to 1. So my question is, if I know that that's 0.402, 0.402 plus what gives me 1? So the way to find that is to take 1, subtract that, and figure out what it is that you have to add to 0.402 to get 1. So that kind of is that an easy way of thinking about it? So if it helps you, you can kind of say that plus blank equals 1, and that kind of helps you sort of figure out, okay, I need to subtract that from 1 to get to what I really want. So that's kind of the question that's being asked. So now someone else asked the question, well, how is this different from the next problem, number 7? Here's the deal. You guys remember that airline problem? Like 71% of airplanes are on time with that last class? Yeah. Now, if I take 2 or 3 airplanes, 2 or 3 flights, out of all the flights, does that affect the probability? Out of thousands of flights? 2 or 3 does not affect the probability out of thousands of flights. But, and same thing here, like rolling a dice, those don't affect each other. But, oh, why am I looking here? If I have children, how many kids do I have? 22 kids. If I take one, even just one kid, all of a sudden the probabilities change. 1 out of 22 is significant. That's like 4% right there. Do you guys see what I'm saying? So we're talking about less than 100 items, and you start taking some from them, taking 1 or 2 matters. You're talking about thousands of items, tens of thousands of flights, or all Americans or all Californians. Taking 1 or 2 or 3 or 4 doesn't affect the probabilities at all. Do you guys see the difference? So that's why this one's different, because now all of a sudden you're not talking about all Americans or all dice or all flights. You're talking about just these 22 kids. So, same idea. I want to find the probability that I get at least 1 girl, right? So, at least 1 girl. You could do this by you could technically do this by drawing a tree, but I think that'd be harder because you'd have to find all these probabilities, right? Boy, girl, boy. Well, maybe we should do that. Maybe it's good practice. All right, I'll do that real quickly. So if there are 14 boys and 8 girls, we had 22 kids. What's probably that I pick a boy? 14 out of 22. Girl is 8 out of 22. Now, if I pick a boy, what's the probability that I pick a boy again?
13 out of 21.
Yeah, now there's only 13 boys left. And how many kids? 21. And then I still have 8 girls left out of 21. All right, so that adds up. 13 and 8 is 21, so we're good there. If I picked a girl first, then let's see, I still have 14 boys left, but now I only have 21 kids. And I only have 7 of them as girls, 7 girls, so 7 out of 21 girls. So everyone okay with how I got that? Okay, so I want to find probably at least 1 girl. So you could find this, probably that's this, right? This one and that one. So 14 out of 22, 22 times 8 out of 21, or 14 out of 21, 8 out of 22 times 14 out of 21, or 8 out of 22 times 7 out of 21. I can find all those, multiply them, and add them up. Or I could just find this one, 14 out of 22 times 13 out of 21, and subtract it from 1 to get these guys. Do you guys see the difference?
Yeah.
So that's what I would suggest. And then you don't even need a tree, because both boys is easy. The first one being a boy, 14 out of 22. Second one being a boy, well, oh, so let me rephrase that. Let me do this over again. So instead, I can just say, well, I can take advantage of what we know, which is the probability of at least one. Did I make a mistake?
Yeah, I'm wondering why it's just two probabilities you're multiplying when you're picking three students.
Oh no! I did make a mistake. Yes. So that's the problem, is that I can't even do that, because then I have to, oh, that's a total nightmare. You got 3 kids, so you can't even do that. I've got to go even further. Wouldn't that be a royal pain in the butt to go another spot, and then I've got 3, 4, I've got 2, 4, 6, 7 I need to calculate and add up. That's even worse. So that's just a nightmare, because this is only 2 kids. I'd have to calculate not just those 3, I'd have to find the other. I'm not even going to bother, because that's a royal pain. That's just nightmarish. So let's not do that, because we have to go even more and find all of these probabilities. Calculate all those and add them up. Instead, I can just find the boy one and subtract it from 1 to find the blue stuff, which is what I want. So what I want is these probabilities here. At least 1 girl. All the ones in blue. To find that, I can either calculate all 7 of them, or I can just calculate the one in red, the boy, and subtract it from 1. It's so much easier. So instead, I'm going to do that. At least 1 girl. Oh, goodness, giving me trouble. Equals 1 minus probability of no girls, right? Out of 3. So how can I find the probability of no girls? So 1 minus probability of no girls. Probability of no girls means really what?
No, all boys.
All boys. Yep. 14. Probability of boy and boy and boy. Right? All boys means and. So what's probably the first one's a boy?
14 out of 22.
14 out of 22. Second one? 21. And then the next one? 12 out of 20. Yep. So figure out what that is, subtract it from 1, and you get your answer. So 1 minus, what did you guys get for the decimal? Anyone? 236. So what everybody else got? 0.764. Does everyone see how this is so much easier than that other tree way?
Yes.
You can't do it the other way, because it's just. I mean, you could totally do it the other way. It just would take you a lot longer, because you have to calculate all 7 of those options. Okay, we're going to move on in 5. Take a picture of it if you need it. Moving on in 5, 4, 3, 2, 1. Okay. Oh, we did this one already. All right. Oh, one thing. Okay, so one thing. All right. Who feels stressed out about tests in general? All right. So here's the problem: is that when you're stressed out, what happens is part of your brain is like thinking about all this other stuff, like, oh my gosh, what if this happens? What if that happens? What if I don't know this? What if I didn't study that enough? So then here's your working memory, right? And you've just taken a chunk of your working memory and you're using it to worry and go down what I call it the what if what rabbit hole. So then you only have like 2/3 of your working, or some small amount of your working memory available to work on the actual problems and use what you do know, right? And so I know it's kind of hard to do, but what I try to tell people is prepare as best you can. Whatever you know is what you know, and then kind of be kind to yourself and say, okay, you've done what you can do. Just go in there and show what you do know. And if you only know half of it or 70% of it, that's okay. Because if you kind of are all right with that, then you can do well on that 50% or that 70%. Right? Whereas if you're freaking out, then you go in there and you know 50% of it, but you freak out, and so you end up doing nothing. And you can't even show the 50% you do know. Does that make sense? And a 5% on the exam is a lot worse than a 50% on the exam. Right? Or a 40% on the exam is a lot worse than a 70% on the exam. So if you just are like, cut yourself some slack and say, hey, I've learned what I can learn, I know what I know, I'm going to be okay with that, and I prepared the best I can, I've learned everything that I can learn, and it is what it is. Go in there and just do the best you can. Does that, you guys kind of understand? And then maybe you want to change some things for next time around. Right? Like I had a game yesterday, and they scored 5 goals on me. I was in the goal. And, you know, some of them it's like, okay, well, that was a good shot. If it's a good shot, you can say, oh, nice shot. That's it. And some of them I'm like, and you got to let it go, right? And some of them it's like, okay, well, this could have happened or that should have happened or whatever. But then you just learn from it. You try not to do it again next time. But again, you got to let it go. Because if you're worried about it and thinking about it and in your head like, oh, I messed up, blah, 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 and I really made a mistake, then all of a sudden, you're off your game for the next shot. Do you see what I'm saying? So the same thing happens with sports and math. There's a lot of similarities, right, with that. It's all performance, right? So just prepare as best you can and just kind of cut yourself some slack and say, I know what I know, and just go in there, right? So that's what I would say, is don't worry about what you can't control, right? And what you don't know, you can't control. What you can control is what you do know. And so make sure that you're good with that, and you know, go in there and you show what you do know. Because that's the key part. Okay. So let's move on to lab problem. Oh, this is actually lab problem 1. My bad. So this is lab problem number 1. It is on the previous page. So it's the very top of it's in your notes. So it's not the last page. It's not the second last page. If there's 12 pages, it's the 4th to last page. Just look for this one. It's the very top of the. So as you're here. Okay, yeah, here we go. Yep, that's okay. No worries. All right, so here's the very last page right here. You guys fold forward, back one, and then back another one. It's right there on that side. So we're going to work on that one. Here's the deal. Let me show you guys a couple things first before you go up. The first thing is we have marbles. We've got 3 red marbles. We got 1 green marble. And we've got 6 blue marbles. Good? I'm going to draw a marble. But this time I'm not going to replace it. I'm going to keep it. So now I have less marbles. Kind of like that thing with the boys and the girls on the bus, right? Or I was on the bus, but the boys and the girls. Now I have less marbles. So now when I draw a second marble, things are changed depending upon what I drew first. If I drew a blue marble, now there's fewer blue marbles, which are really white marbles. So I have less marbles, and there's same number of red and green, but fewer blue. If I draw on a red marble, then for my second draw, now there's fewer marbles and 1 less red, right? But the same amount of blue and white, or green. If I do the green one, now I can't draw a green one again because there's no green left. So kind of some things to think about. Draw a tree. Absolutely, you need to draw a tree. So draw a tree. So you can practice that 9% of your exam will be drawing a tree with the probabilities on the branches. And if you're at home, pause the video here and resume it when you're done. All right, let's take a look at what we got so far. So you could draw a red one, a blue one, or a green one first. If you draw a red one, then for the second draw, you could draw a red, a green, or a blue, right? And you'll have 1 less red one. You only have 2 Red ones out of now 9 marbles. You'll still have 1 green one out of 9, and you'll still have 6 blue ones out of 9. This is not connecting very well. Okay. If you drew a, oh, sorry, I meant to do green, and then blue, my bad. If you drew a green one first, then you have red, well, green, actually there's a 0 chance of drawing a green one, because there's no greens left, or blue. But you still have 3 red. And then you still have 6 blue. If I drew a blue one first, then I could draw a red, green, or blue. And again, 3 red ones left out of 9, 1 green one left out of 9, and 5 now blue ones out of 9. Now the questions were, there's some questions. You can just get over here. Red then green. All right, red then green is.
You got a projector down.
Is this path here? It's just going to take a minute to do that. See which way it's going. I think. Yeah. Okay. So if I do red then green, then that's going to be red, 3/10 chance of red, 1/9 chance of, oh wait, did I say red then green? Yeah. That's going to be 3/10 chance of red, and then green, 1/9 chance of green. Remember, as you go along the branches of the tree, you multiply, and you should end up. Why do I feel like this is different? Is this what you guys got? Yeah. Okay. Oh yeah, 3 out of 90. Or you could have written .033. Is that right? 33. And that'd be okay too. I don't care. I don't care whether you give it to me as a fraction or as a decimal. I don't care. As long as it's accurate. But if you're gonna do decimal, I need 3 decimal places. Everybody on board? 3 decimals. Okay. Oh, sorry, that was the first one. Red then blue. Red given. Ooh, the next one is red. So that's that one. Red given blue. So that line straight up and down means given. Right? So red given blue. All right, everybody, question. If it's red given blue, what's the probability that the first draw was blue? 100%. Given blue means you know it was blue. So red given blue means I know blue happened first. Let me see that again. Red given blue means you're given blue came first. So it means 100% you know the first draw was blue. So given I'm standing at blue, red given blue means you're standing right here. If I'm standing right here, what's the probability of drawing a red? 3/9. Someone see that? So it's super easy. Don't make it hard. However, on average, 1/3 of the class typically misses that problem on the exam. Red given blue means if you're standing at blue, what's the probability of red? It means you know that blue has happened first. Okay. So they were like, red given I drew a blue marble first. Well, given I drew a blue marble first, I now only have 9 marbles, 3 of them are red. Okay. Next question was both the same color. How can they both be the same color? What's one way? Somebody give me a way. How can they both be the same color? Red, red. Okay, red, red. That's one way. What's another way they can both be the same color?
Green, green.
Green, green. What's another way?
Blue, blue.
Or blue, blue. Someone said or blue, blue. Ors we do what? Add. So I'm going to find these 3 things and add them. So red, red. 3 out of 10 times 2 out of 9. That's 6 out of 90. This one is 1 times 0, so it's 0 out of 90. And this one here is going to be 6 out of 10 times 5 out of 9. So that's going to be 30 out of 90. So altogether, we're going to end up with a total of 6 out of 90 plus 30 out of 90, 36 out of 90. Oops. Okay, great. Now red on the second draw. Aha. Which ones are red on the second draw? Well, this one, right? This one. And this one. So you can find those three. So the first one would be 3/10 times 2/9. Second one would be 4/10. Oh, sorry, 1/10. I'm sorry, I can't read my writing because it's that bad. It's just that bad. Times 3/9. And the last one is 6/10 times 3/9. What am I going to do with these? It's red, red, or green, red, or blue, red, right? Or as we add, thank you. So I'm going to add those three things. So I'm going to end up with 6 out of 90 plus 3 out of 90 plus 18 out of 90. So 27, is that what you guys got, 27 out of 90?
Yeah.
God, I feel like I did not get that last class, so I must have made a mistake. And nobody corrected me on it. All right. Good deal. Oh, and incidentally, this reduces down to 3 out of 10. Which is interesting because here's the thing. Here are my marbles. They're in the bag. If I don't know which one, and whatever spot they come in at is whatever order I draw them out at. So in other words, this one's first, that one's second, that one's third. So as I shape them, if I don't know which one's first, what's the probability that that green marble will end up in the last spot? There's 10 marbles, right? What's the okay, let's do it this way. There are 3 red marbles. What's the probability that a red marble will end up in the first spot? 3 out of 10. Does someone follow me? What's the probability that red marble will end up in the second spot? 3 out of 10. What's probably the red marble ends up in the last spot? 3 out of 10. So if you don't know the other spots of the marble, then it's not given anything. The red marble, there's a 3/10 chance of it being in any spot. Is that, do you see?
Yeah.
So that's the thing. If you don't know the first one, then that's the same thing as probability of any of the initial part. There's 3 out of 10 red ones. It could be anywhere. Okay. But you can just do it this other way. That's just as easy, doing the adding part. Okay, let's take a look at some other stuff. Lab problems 6 through 9. I don't think that we finished all of those last class. So 6, 7, 8, 9, those 4 problems, work on them. And then we'll go over them. So we have 6 minutes to work on them. So pause, and then we'll go over them. And you pause the video now, and then we'll go over it when you guys are done. All right, so this one we actually did in class, so maybe I'll skip this one. Well, yeah, I got to do it ready for that class. All right, so 7 colors, 7 exterior colors, 3 interior colors. So I'm making choices. I'm picking an exterior color, an interior color, interior style. I'm picking a transmission and an engine. So I'm making 5 decisions. 7 options for the first, 3 for the next, 3 for the next 2, and 2 for the other 2. So you guys end up getting 252. Great. Next one. 7. So here, does order matter? Does it matter? Yes, totally. I'd much rather have it such a big $10 gift card. So I'm picking 3 items. I have 112 options for the first, 111 for the next, 110 for the next. Good? Multiply them. Next one. President, Vice President, Treasurer, and Secretary. So think like this. Is each one getting assigned something different?
Yes.
Yes. So order matters. Yes. So 4 positions. How many options for the first? 12. Next. 11. Next. Last. 9. Great. Good. one. Replicate it. All right, how many people am I picking? Picking 3 prizes. Does order matter? Are the prices different or the same? They're getting treated differently. So order matters. So how many for the first? Next one? Last one? Okay. So on the exam, you need to write out for me what times what, and then your answer. Last one, they're all $80. Does order matter now? No, they're all the same. So it's chaos. So you do the first thing, 200 times 199 times 198, but then you divide out the duplicates. 3 times 2 times 1. Good? Alright, now they have a good couple of days. Good luck on Thursday if I don't see you tomorrow. Tomorrow, Coxville. You can come at 2, 5, or 7:30 if you're coming tomorrow.